Hey everybody. Today we are going to look at fundamental skills for physics. Fundamental meaning that they are underlying skills. They are just so important as we go through and we learn Physics 20. So first skill that we want to talk about here is measuring and measurement. So an important thing with this is to know that our measurements can only really be so precise, and it's based off the measuring devices that we use, whether that's a ruler or stopwatch or whatever. The kind of general rule of thumb is we're only allowed one uncertain digit, and it's always our last uncertain digit. Cool, so let's check it out with this ruler off to the side here. Let's check out an example. So on this side, I've got a ruler that looks like goes down to millimeters, and here only going to centimeters. So let's do the height first. This to me looks like it's going to be okay. So there's 1 centimeter. There's 1.1 centimeters, and then it's not quite at 1.2. So that's where we got to make that estimate right in there. It's definitely not 1.1, and it's definitely not 1.2. I might estimate this to be 1.1. I'm going to say 6 because it looks a little bit closer on my smartboard here, a little bit closer to the next increment. And then, of course, we need units because what is a measurement without a unit? If I just said that, like, oh, I rode my bike to school today, it was 10. You have no idea what I'm talking about. It was 10 minutes, it was 10 kilometers, it was, 10 revolutions of my wheels. You have no idea. So units, just beyond important. Okay. Let's look at, oh, and look at that, first mistake of the day, wrote that in the wrong section. So the height I estimated to be 1.16 centimeters. The width, the next thing that I want to look at, and this is a little bit trickier here, it's a little bit less certain about these, right? Because it says, okay, I got 1 centimeter, there's 2 centimeters, 3 centimeters isn't even shown. I'm going to imagine that it's over here somewhere, so 3 centimeters somewhere over there. So I'm going to estimate this to be, so it's not 2, it's definitely not 2.5, it's pretty close to 3, maybe 2.8 or 2.9 centimeters. And you'll notice that 0.9, that's my uncertain digit. That's the one that we're making the estimate on. And for the height, it's the 6. We're sure about the 1, we're sure about the other one. It's the 6 that we're uncertain of. This leads us into these measurements. This leads us into significant digits. Because if we're only sure that it's about what, like, we know the width is 2 and we're guessing on the 0.9, I shouldn't say guessing, estimating on the 0.9, we can't pretend that we know it's any more specific than that. We cannot say things like, oh, it's 2.9, I got the decimal in the wrong place, 2.9000, we have no clue if that's what it is. Right? So we can't pretend, and that's where significant digits come in. So significant digits are for measured quantities. Measured quantities. Here's how you do it. You find the first non-zero digit from the left. That digit is significant, and all of the digits to the right are significant. Cool. So for measured quantities, find your first non-zero. All the digits to the right, including that first one, are significant. Cool. If you're counting something, or if it's a definition, well, those are exact. Those are exact. We have an infinite number of significant digits because we are infinitely sure. So for example, how many people are making this video right now? 1 person. That's me, and I am infinitely sure that there is just 1 person making this video right now. So I have all the significant digits. So typically, you don't even really include that in your questions, because when we start to look at the mathy stuff, we're always looking for the least number of significant digits, not the most, and infinite is clearly the most. So let's do a couple quick examples here. Okay, 0.015 seconds. Yeah, check it out. Okay, so there's my first non-zero, and then I got a 5 after that. Oh, that's 2 sig digs. Nice. Okay, what about 0.0150? Seems like the same measurement, but it's not quite the same because now we have 3 sig digs. Nice. 15 people. 15 people. That's something you can count. You either do or don't have 15 people. You're either infinitely sure about it or you're not sure at all. This one, I think we would be infinitely sure. Infinite significant digits. And 1 centimeter is equal to 0.01 meters. Sounds like a definition to me. And by definition, that has got to be perfect. That is infinitely accurate. Or sorry, infinitely precise, I should say. Okay. So mathematical operations and measured quantities with significant digits. So when you're performing these, there's two rules that you should know about. One that you should really, really know about, and one that you should kind of know about. So the first one is talking about multiplication, division, and everything that's sort of based off multiplication, division, like squares and square roots and stuff like that. So the key is we're always looking for the least precise measurement in the question, and that's the precision that we should have in our answer. So in other words, when we go through and we look at this, the least, if I could spell, least sig digs in question is equal to the number of sig digs in answer. So that is extremely shorthand. I'll say that again because I'm kind of switching my abbreviations and stuff, but the least number of sig digs in the question, so the least number in the question should be the number of sig digs that you have in your final answer. Cool. Okay, so let's go through and let's check it out. The first one, I've got, let's see. Oh, there's the old calculator way on the other side. I've got, excellent, 5.0 times 0.689. So 5.0, in your calculator, do you really need to put the 0.0? Your calculator doesn't care, but you should. So times 0.689, that's going to give me an answer of 3.445. 3.445. We'll talk about the units in a second. Now, when I go through and I look at this, I got to look back to my original question. So I've got 2 sig digs versus 3 sig digs. My question, I've already got 4, so that's a bit of an issue. So I need to round to the least number of sig digs from the question. That's 2 sig digs, so that means 3.4. I got to look after that 4, see what comes. It's another 4, so you know regular rounding rules, 5 and above round up, 4 and below round down. So 3.4, we should think about this unit for a quick second here. This unit, you know that when you divide any number by itself, so for example 5 over 5, it makes 1. If it's 10 over 10, guess what it makes? 1. And then 1 times anything, so 1 times 3, well that's just 3. 1 times 5, well that's just 5. So 1 times anything is itself. Those are important things to kind of remember for this. Units do the exact same thing, right? A little bit harder to see, but units do the exact same thing. So I'm looking at these units. I've got meters over seconds. So meters over seconds times seconds. So in other words, if I do this in a slightly different order, I've got seconds divided by seconds. Those are going to cancel out. Those are going to make 1. And then 1 times meter is just meter. Well, that means I've got 3.4 meters. Excellent. I'm going to show you one more example here. Then you can put the video on pause. You can try out the rest. I'm going to show you this one over here. This one does include some adding and subtracting. That is the other rule that we should know. I'm just going to mention this here. You won't use it a ton in Physics 20 or realistically in Physics 30 for that matter either. But you should at least be aware of it. So for adding and subtracting, here it is. The rule is about decimal places. The least number of decimal places from your question should be the decimal places in your answer. Cool, so all about decimal places. So when I go through and I eventually turn the calculator on, I think I have 2 calculators open here. I'd go through and I need to keep in mind some order of operation stuff. So I've got 12.5 meters plus 8.5 meters and only all of this stuff is together on top of my fraction or in the numerator. I need to take all of that stuff and divide it by 4.0 times 10 to the negative 3. So it's kind of like that's in brackets, even though those brackets aren't necessarily shown. So it's one way that we can absolutely plug that into our calculator. I could do bracket 12.5 plus 8.5, close bracket, divided by 4 times 10 to the negative 3. Oh, and if you don't know about that e function, so I pushed second function, comma, which is e, it's second function, it's a comma with an e on top. This is a fantastic thing. This is just a wonderful, wonderful, wonderful thing. This means times 10 to the power of whatever comes after it. So I'll show you on the calculator here. So 4.0 times 10 to the power of negative 3. So I hit enter. I should have 5,000. Hey, where'd it go? 5,000 5,250. We'll think about those units again in a second. 5,250. Wow, might as well write it. I've got meters on the top divided by seconds, meters per second. I don't like having numbers without units. It kind of weirds me out. So for this one, this one's a little bit bigger. We need to start to think about scientific notation, because there's no way when I go through and I look at the top here, and this is kind of a weird one, we'd have to do both rules, but long story short, I guess, well, we'll skip a little bit here. We've got 4.0, that's 2 sig digs, so I'm going to have 2 sig digs in my answer. So that's the 5 and the 2, and I got to decide with that 2 whether it's going to round up or round down. What comes immediately after, it's another 5, so it's going to round up. So 53, but that's not the same as 5,250, so this is where the scientific notation comes in. The decimal place was originally there. Every time I move the decimal place, I'm multiplying by 10. So from 1 to 10 to 100, all we're doing is moving the decimal place over a little bit every time. We're multiplying by 10 and multiplying by 10. So that's going to be 5.3 times 10 to the power of however many times we move the decimal place. 1, 2, 3 times. We moved the decimal 3 times to get it there. So 5.3 times 10 to the power of positive 3 meters per second. I know it's positive 3 because it's a very large number, bigger than 1. If it's a small number, smaller than 1. Cool, so there's that one. You can put your video on pause. You can try out others if you want to. I'll have an answer key up in a split second. Go ahead, put it on pause right now. Alrighty, so I got some answers up here. Just go through a couple of them in a little tiny bit more detail. This one is kind of interesting because it has 2 and pi. You might recognize this from some other like mathy classes. The 2 is probably an exact value. The pi, you've got infinite significant digits with pi. Please make sure that you actually use your pi button on your calculator. So for most of us who are using these TI-83s, TI-84s, push second function, the up arrow, you'll get pi, and it will tell you like the whole entire pi. So you don't really need to worry about memorizing 3.14159, etc., etc. Let's see, this one I hope was fairly straightforward. B was fairly straightforward. You probably have some excuse me, have some order of operations to deal with there, but not the end of the world. For D, rotations per minute, we've got 4 sig digs, 4 sig digs. This one might be a little bit confusing because your calculator would just tell you 650, but we need 4 sig digs, so it should be 650.0 rotations per minute. And then the last one I think was probably the most straightforward. You might remember it from Science 10 in your kinetic energy formula. The 1/2 does not count as significant digits for that one. Cool. Next page. This example I'll leave up to you. It's a little bit more of a practical example. The answer that you would end up with in your calculator is 16 meters, but hold the phone. Well, I got 3 sig digs here, and I've only got 1 sig dig here. So the best estimate that you can actually have is only 2 times 10 to the power of 1, which would equate to 20 meters. So that's the best you can really get with that, because that 5-meter measurement, not very precise. Okay, last thing to talk about in this video, we'll try and go really quickly. Scientific notation. It's a method for writing numbers that are a multiple between 1 and 10, not including 10, to the proper power of 10. So remember, we just talked about every time you move the decimal place, you are excuse me, multiplying by 10 or possibly dividing by 10. So if we're multiplying by 10, we're going 10 to the power of a positive exponent. If we are dividing by 10 each time, that's 10 to the power of a negative exponent. So when would we multiply by 10? When we have really, really big numbers, larger than 1. When would we divide by 10 or multiply by 10 to the power of a negative exponent? That's where we have these smaller numbers. So again, the rule is we need 1 non-zero, then our decimal place. So non-zero digit, and you're only allowed 1 of those, then the decimal place, and then whatever else you need to finish off your correct sig digs. So convert each of these to scientific notation where possible. So we'll look at these. I see at least 2 of them that we'll probably go the other way, go to decimal notation. So for this first one, I'm starting with my decimal here. I need to move it so that I have one non-zero in front of it. So I'm going to move it 1, 2, 3 times. So it's going to be 6.00 times 10 to that. And we moved it 3 times. It's a small number, less than 1. It's like we're dividing this number. So 10 to the power of -3. And then, of course, we still need that unit. This one, so 527. This one, I'm going to move it 1, 2 times to get 5.270, and it's going to be meters still, but we moved it 2 times. It's a large number, so we're going to multiply it by 10, so I want a positive exponent of 2. Cool. Okay, the other is fairly straightforward. This should be 5.27 times 10 to the power of 2. Same thing, but one less sig dig. This one should be 4.0 times 10 to the power of -1, because you only have to move the decimal place once. And of course, we want kilograms. Oh man, look at this. Forgot those meters. When we're looking at, we'll just do F here, and I'll kind of do it off to the side because I'm getting a little bit messy here. When we're looking at scientific notation, we want to put that into decimal notation. We just need to do the opposite. So 5.40. I have a positive exponent, so I know it's going to be a pretty big number with a positive exponent. It's telling me that I need to move the decimal place 3 times. So 1, 2, 3 times. I got this empty little bump in there. I'm just going to fill that with a 0. So that's approximately 5,400 in this case. Joules. Cool. So we'll pause that video here. Next video we'll check out is unit conversions, but we'll get to that in a moment.